Alright guys, so in this section we're going to transition into multiplying polynomials, multiplying specifically a polynomial by a monomial. Okay, in section 8.1 we were adding and subtracting. In this section we're going to multiply. So if we look at example 1, it says simplify by using the distributive property and be sure to write in standard form. Okay, so for example A, what we see here is we see 8x times the quantity x minus 8. So we are going to distribute here, and what we're going to do is we're going to draw arrows from 8x to that first term, and also 8x to that second term, that minus 8. Okay, so we break this down into pieces. What do we see? The first thing we see here is 8x times x. Okay, so the principle here is this. If you remember multiplying exponents, we combine the numbers with the numbers and the variables with the variables. So the number I see in front is 8, and then I multiply it with the number I see in front of this term, which is just an invisible 1. 8 times 1 is equal to 8. Then I see, if I change the color here, x times x. Okay, it's x to the first power times x to the first power. What do we do with the exponents for multiplying? We add them. 1 plus 1 is 2. It should be x squared. I'll go back to that blue. Okay, 8x squared is my first term, and then for the second term, I see 8x times negative 8. Okay, all we have to do here is combine the numbers with the numbers. 8 times negative 8 is negative 64. And then I've got to remember that leftover x times 1 is just x. My final answer should be 8x squared minus 64x. Okay, if I look at the second one, I see negative x cubed times 9x to the fourth minus 2x cubed plus 7. So I'm going to use the distributive property and I'm going to draw my arrows. Go a little bit quicker this time. So I've got negative x cubed times 9x to the fourth. Okay, I see a negative and I see a 9. Negative times a 9 is negative 9. That's my first number. Okay, then I see x cubed times x to the fourth. Okay, what do we do with the exponents for multiplying? We add them. 3 plus 4 is equal to 7. I should have x to the 7th power. Keep going. Go my next term. I see a negative times a negative 2. Negative times a negative is a positive, so this become a plus 2. X to the third times x to the third. Same base, add the exponents. It would be x to the 6th power. And then the last thing I see here is negative x cubed plus 7. Negative times a 7 is minus 7. And then I can't forget about the x cubed. It's got to stay attached. This is my final answer in standard form. My exponents are going descending order. Okay, for the last one, it looks like it's kind of two questions squeezed together. I've got z squared times z plus 3 minus 4z times z minus 5. Okay, so this is two separate distributive property questions. We'll take it one step at a time. I got z squared times z, and I got z squared times positive 3. Z squared times z, remember there's an imaginary 1 up here. Z squared times z to the first, should add the exponents, should have z to the third. Then I've got z squared times plus 3, should be just plus 3z squared. Okay, then do the exact same thing for the second question. I've got negative 4z times z, and I've got negative 4z times negative 5. Okay, negative 4z times z should just give me, I'll have a negative 4 in front, and then z times z should be z squared. And then the last piece I see here is negative 4z times negative 5. Negative 4 times negative 5 is positive 20. And then I got a z left over. Okay, so those are the individual pieces, but we got to remember we can combine like terms if it's possible. So what I'm searching for are any of the variables that have the same exponents. So I search, do I have any other terms that have an exponent of 3 for z cubed? No, so it doesn't combine with anything. But then the next term I see here is I see positive 3z squared. And what I realize is that this term can combine with this term. They both have the same base raised to the same exponent. They're both z squared. So if I have three z squareds, and I subtract 4z squareds. 3 minus 4 is just -1. It should be a minus z squared once you squeeze these guys together. But nothing else is combinable, so I leave the rest as is. Z cubed plus 20z. This is my answer in standard form with terms combined. All right, same sort of process here. The questions are just slightly more complicated. It says simplify the larger expressions. Okay, but the process is still the same. The first thing I have to do is I've got to distribute. I see 3 times all of this stuff on the inside. First step, let me draw my arrows. Got here, here, and here. Okay, so the first piece I see here is 3 times 2t squared. 3 times 2 is 6, and then I got the t squared at the end. Okay, if I keep going, I've got 3 times -4t. 3 times -4 is -12, and I attach the t at the end. And last piece I see here is 3 times -15. 3 times -15, if you use the calculator, you should get -45. Okay, so that's the first piece. And then the second part of this question is another distributive property. I've got positive 6t going to 5t, and I got positive 6t going to 2. So let's clean it up a little bit. 6t times 5t. Well, what's 6 times 5? It should be positive 30. And then t times t is t squared. And the next piece I see here is 6t times positive 2. 6 times positive 2 is positive 12. And then I attach the t at the end. Okay, so I've distributed everything. Now my job is to combine like terms and put it in standard form if possible. Okay, so the first thing I see here is I see some terms that have t squared. And I ask myself, is there anything I can squeeze together? This 6t squared can combine with this positive 30t squared. They've got the same base, raised to the same exponent. They're both being raised to the second power. So what I'll do is I'll just add. 6 plus 30 is equal to 36, and then I keep the base and the exponent as is 36t squared. Okay, then I search for other things I can combine. I've got a -12t and I've got a plus 12t. Well, if I've got -12t and then I add 12t's to it, basically what's going to happen is if I have -12 plus 12, these guys are going to cancel each other out. Okay, there's not going to be any t's remaining. It's going to be 0. And then attach whatever is remaining. I've got a -45 left. That's going to be the final piece. It just carries down towards the bottom. I'll switch back to the orange. -45. Okay, this is going to be my final answer in standard form. Okay, remember always the constant or the number goes last.